we are going to discuss about that BiCMOS cascaded amplifier. So we know that why we have to go for cascaded. So why you have to cascaded more than one amplifier? That is, we have to get a required output. Your output means we are going to concentrate only 4 parameters in this amplifier circuit. One is voltage gain, another one is current gain, and 2 more things are input impedance, output admittance. Some places they will call it as output impedance, and some of the book they will be call it as output admittance. Right. So these 4 parameters is playing a major role while selecting an amplifier. The first one is why we have to go for cascading, why we have to connect more than one amplifier with others. So that is only we're going to call it as cascading. The output of one amplifier which is connected to the input of another amplifier, that is we're going to call it as cascading. So why we have to go for this kind of cascading? To get the required output. For example, I am having an amplifier. The amplifier output is not met my requirement. That output impedance is very low. No, sir. My requirement is I have to get a higher output impedance. So what we have to do? We have to improve the output impedance. That can be improved of a additional amplifier. Okay. So we know that here we are going to discuss only 2 types of amplifier. One is bipolar junction transistor BJT used amplifier. Another one is FET used amplifier. Okay. The BJT used amplifier will be having 3 configuration: common base, common emitter, and common collector. We know that common emitter is shifted one and with a high voltage gain and current gain. Common base is at current gain is a unity, that negative sign, but that output impedance is very low. Okay. Similarly, the common collector is current gain is high, but voltage gain is unity. Okay. So based on the requirement, we are going to select the required configuration. Similarly, in that FET type amplifier, common drain, common source, and common gate amplifier be there, and each and every configuration having the different parameters. Here, I am having initially one stage of amplifier. I want to improve that output impedance of that respective stage. So I am going to additionally add it. So while adding this kind of one more arrangement, amplifier arrangement, what will happen? One of the parameter might be met your requirement, but what about the frequency response? It will be the frequency response of your total entire unit. It will be low or high, or it will be disturbing any of the parameters. We have to analyze it. Okay. And not only met that requirement of these basic 4 parameters, we have to see that conductivity of that bandwidth. Bandwidth can be found out with the help of frequency response. If that system will be operated low frequency or high frequency ranges, or it can be support for high frequency output. So that is also we have to take it account while discussing that or while connecting more than one amplifier in cascading. Right. So here we are going to see that cascaded BiCMOS amplifier. So from the title itself, bi means initially I am going to use BJT, bipolar junction transistor. So they are using only the 2 letter Bi. And MOSes, we know that metal oxide semiconductor, any one of a FET amplifier. Okay. So these 2 things we are going to club together to get the required output. So that is only at aim of this title, BiCMOS cascaded amplifier. Okay. So here they are given that explanation. When the amplification of a single stage amplifier is not sufficient for a particular purpose. So a single stage output is not sufficient for the particular purpose. When that input or output impedance is not matched with your correct magnitude of your intended application. So that we want to improve these parameters. So that's why we are going for one more amplifier setup to is connected series with cascaded with your first stage. Is cascaded amplifier. So the main function of cascading the stages, that will be that overall gain is increased. I achieved the required level. So the gain of your overall stage will be increases. And this is a simple schematic diagram of your cascaded amplifier. Will you please look at that? This we are going to call it as a simplified equivalent circuit. From this equivalent circuit, we are going to obtain that H parameter table. So here there one voltage source is there, one resistance is there. We are using that Q1 is one set of transistor, Q2 is another set of transistor. Here they are using both the things are a bipolar junction transistor. So by using these stages, we have to get the required output. So we have to look into that. First one is a common emitter amplifier configuration. Second one is also common emitter amplifier configuration. So what will happen? First stage it is shifted 180 degree your output. Second stage again 180 degree shifted. What will happen? That amplification is in phase with your input side. So there will be current gain is amplified, voltage gain is also amplified. There will be no phase shifting after that second stage. Simply, we will discuss in that common emitter amplifier, the voltage and current gains are increased, but that shape of your magnitude of your voltage, what will happen? 180 degree shifted. If I am combining two stages in a common emitter amplifier, what will happen? That voltage current gain is also increased and phase shift also is avoided. It will in phase with your inputs voltage waveform. And also voltage gain is increased twice. So that's it. They said that while combining more than one stages, the voltage gain is achieved the required level. You may increase. Based on the requirement only, we are going to connect it more than one amplifier. Okay. So here they are given the statement is the voltage gain. The resultant voltage gain is given by that product of individual voltage gain of each stages. Okay. And we'll look into that simply two stages be there. The voltage gain which is equal to V2 divided by V1. That is that simple voltage gain of a single amplifier with that angle shifted. Here A1 is that current gain of your first stage, and theta 1 is the phase angle between the output and input voltage of this stage. Suppose the system has more than one number of stages. So how will you getting that voltage gain of your last final stage? I'm taking as nth stage is that we know that with two amplifier or four amplifier, how many n stages will be there? Suppose if we like this, we have to find the voltage gain using this formula. The voltage gain A suffix Vn. A suffix V is we know that is a voltage gain of your nth gain. N stage amplifier, that is AI into RLN. What is RL? RL is the load resistance. N means nth stage, the last stage, load resistance, and also the input impedance of your nth stage. So based on these two parameters, we are going to find that voltage gain of your that nth stage of your amplifier. Similarly, we have to. My voice is audible, no?
Yes, audible.
Right. And that this is the way to find that cascading amplifier voltage gain. Similarly, we have to go for other parameters, current gain and the input impedance of your nth stage is given by the current gain is AI for the nth stage. So A suffix IN is equal to minus HFE. If that common emitter amplifier we are using, that is that HF means we know that forward characteristics of your H parameter. So minus HFE divided by 1 plus H H naught of E and reverse parameters of your common emitter amplifier. Similarly, I am going to calculate input impedance for your nth stage by using this formula HIE plus H naught of E H of N into AIN into RLN. Okay. So here this is a way to find that output of your nth stage in your cascaded amplifier. And now only we are going to slightly enter to our respective title, that is BiCMOS cascaded amplifier, and some places they will take as BiCMOS cascaded amplifier. Anyhow, from the title you will come to know we are going to combine two amplifier. And one is bipolar BJT, another one is FET amplifier. Okay, here they are given a simple way to understand of your common drain amplifier. In the FET, drain is taken as a common terminal. So that is first stage is a common drain amplifier. Second stage we are taken as a BJT. BJT is a common collector amplifier. So here a common drain and also common collector cascaded. Okay. Here first stage is common FET. Second stage is BJT. So if you combine these two amplifier, what will happen? So what about your output parameter? Output parameter means voltage gain, current gain, input impedance, output impedance. So how will be changes while combining these two categories, two type of amplifier. So we know that in that common drain amplifier, your input impedance is infinity range. If it is the input impedance is infinity, we have to know that previous stage. This is taken as the first one. Suppose that input impedance taken from a input of another previous stage, that is also must be a high. Then only they will be getting that input impedance is high, and that output impedance of your drain amplifier is very high. No, sir. My requirement is high input impedance and output impedance is also low. Then only the respective amplifier can be applied to my required application. So we want to reduce your output impedance. How can we reduce the output impedance? We might be use a common collector bipolar junction transistor amplifier is given that output impedance is very low. So what I am doing, I am going to combine these two amplifier, one FET and BJT common collector. So finally you will get output impedance is a very lowest one. Okay. So that here aim of this connecting these two things is the input impedance high, but we want to get the output impedance a lower one. While using only FET type amplifier, only the first stage you will be getting a higher output impedance. No, sir, I want to get a output impedance a very lower one. So for that purpose, I am going to select a BJT common collector. So from this BJT common collector amplifier, output impedance is the very lowest one. So we are going to see that mathematical expression, how we are going to get that while combining these two amplifier. The statement is given. So this is a common drain and common collector voltage buffer. They are given the name is voltage buffer. Buffering means it is going to boosting. Okay. So since that input impedance of your common drain is infinity, and they can couple very well with that previous stage. The previous stage must be at higher output only. It can be coupled with the stage, and also that common collector we are using, that is a second stage. In this common collector, that output impedance is at is compared to your trans conductance value. Due to the trans conductance value, that output impedance is at controllable one. That combining these two category, common drain and common collector, high input impedance, lower output impedance will be applied. And we don't know about the frequency response. We have to know whether this cascading amplifier. That is also we are going to see one by one. So here what we are taken, there is another combination. In this combination, we are taken as first stage is at a current source FET amplifier, not first stage. In FET type, I am going to select the current source amplifier, and BJT I am going to select the common base amplifier. So here I am separately I am seeing both the type of amplifier. One is FET amplifier. I have selected that current source, common source amplifier. If it is common source amplifier, what will happen? That input impedance is a higher one. The voltage gain is also will be at a higher value only. That is only. But output impedance is also high. You have to remember that common drain or common source, the output impedance be a higher one and input also is a infinity value. Okay. So this is way to simply remember comparison of common drain and common source. If I consider our BJT bipolar junction transistor in a common base configuration, in this common base configuration, input impedance is low, output impedance is high. For input impedance is low means how can we connect it with the output of your common source amplifier? Because common source amplifier output is higher value, no? Higher value, it won't be taken as that input one. So we have to change some little modification. Then only it will be help us to get that required output. Okay. And also we know that in that common base amplifier, that is a current buffer, that current gain is at unity, in that it will be maintained the unity value, a negative sign. That is the aim of your common base amplifier. Here voltage gain is increased, but current gain is a unity only in common base amplifier. Okay. The next one is this is a way to coupling. Previously, what we did, the output of FET connected with that BJT. No, sir. Here, output of transistor is connected with that FET amplifier. Because why we have connected like this? The common base amplifier input impedance is low. Once input impedance is low, the previous stage is that output impedance of the previous stage also must be a lower value. Then only will connect it. And output impedance is the highest one. We'll look into that common base configuration. In this common base configuration, will you please look at that parameter? In the common base configuration, input impedance is the lower one. If it is a lower one, we have to get previous stage is at lower case only. So we cannot connect common base over that FET amplifier, because FET amplifier output is a higher output impedance. So that's why what we are doing, we are going to reverse. First one is BJT, next one is FET amplifier. If we connect it in this manner, what will happen? We may connect in this manner also. Here the first is we are using that BJT is at BJT configuration. From this common base, we are going to connect a common source FET amplifier. We are going to take in the output. This is a way to develop the circuit be like this. So if you are connected in this manner, its respective equivalent circuit will be getting in this manner. The respective equivalent circuit means we want to avoid that more than one sources, and this is to help us to develop that H parameter value. Okay. So if you simplify this kind of simplified equivalent circuit for a common base BJT with that common source FET amplifier, you will be getting that output impedance. The output impedance is very higher value only, and also our input impedance isn't the limitable one, and the input impedance of your BJT is at very lesser value, 100 kilo ohm only. That is at input resistance is also at is a controllable one in our combination of these two categories. Okay. So here we are going to obtain that other parameters. We know that trans conductance is that easy way to find it is that output of your current gain divided by the source voltage, input source voltage, will be getting a trans conductance, and that is denoted by symbol of G suffix M. Okay, so that G suffix M is we are going to take this kind of amplifier is a controllable one. Once the trans conductance is lesser, our output impedance of that entire amplifying system is a higher value. Okay. So in this type of coupling, BJT with that FET amplifier, what we are getting, the output impedance be a higher value only, and also that it will be applicable for a high application. The frequency value is also we have to remember. That's why they are given the statement. It is same as that current source amplifier itself. Why could we want to add that common base? Okay, so that is only I am given that the frequency response, that a higher frequency response. I am giving that frequency response separately for the two types of amplifier, current source and also common base. Then we are going to combine. So this is we are going to simply recollect the data, frequency response for individual stages and frequency response for combining these two stages. The first one is it voice is audible?
Yes, audible, sir.
Or if you feel any difficulties, because I am simply teaching with the help of slide, so physically discussing anything. Yeah.
No, sir.
Because the simple way to understand, because the aim of this BiCMOS is why we have to go for cascading this kind of amplifier. First stage is we are taking first stage is FET, next one is BJT. If you are combining both the things, what is your output of your system? And next one is, if I am using, first one is BJT, next one is FET amplifier, what about your output response? So the output response is nothing but that is only required parameter. I need this kind of required parameter. So based on that requirement, I am going to select the type of amplifier, cascading amplifier. Right. So in our syllabus, they are given us BJT combined with the FET amplifier BiCMOS. So BiCMOS means we are discussing that initially BJT, then was FET amplifier, that is at BiCMOS. Either common source, common gate, or whatever it is. But we have to know that if the system is, they are simply asking, explain about means you might be use whatever you want. Suppose they are mentioning, will you please combine common source, combine with the common base amplifier. You have to give the justification, explanation. So why taken as transit as a first amplifier? Why are taken as that input impedance is very lower impedance for a common base amplifier. So lower input impedance means we have to take as that first stage. Higher input impedance means we are taking this one, the second stage. Because that output of a current source, common source amplifier is at higher output impedance. Adanala we couldn't connect with your so first we have taken as BJT the first and FET be the second one. That is you have to understand. And now we are going to discuss about the frequency response of your common source. So from this simplified equivalent circuit, this is already we are discussed. This is a simple equivalent circuit of your common source amplifier. Okay. Common source FET used amplifier. So from this circuits we have obtained that output impedance. Here output impedance is nothing but R dash of output. That is that output impedance. Because and each and every textbook they will be follow a different notation, but no need to confuse. We are going to use the term is only 4 term: voltage gain, current gain, input impedance, output impedance. Okay. So R dash means we have to take as output impedance. Okay. R dash of out is output impedance. For this kind of FET amplifier, it will be depends on your load resistance, also your trans conductance. Okay. That this kind of amplifier you'll be getting at output impedance is a very highest value. That output impedance is very high only for your using your common source FET type amplifier. The second case is frequency response of a common base amplifier. We are going to express in terms of trans conductance parameters, or might be expressed in terms of H parameters also. By using this equivalent simplified circuit, this is an equivalent simplified circuit for our common base BJT amplifier. If you're using this kind of circuit, we know that the input impedance of your common base amplifier is very lesser one, and the output impedance is the highest value. Okay. So that is also we are going to obtain the input impedance is equal to 1 by GM. But GM is trans conductance. We know that current divided by voltage source, that is we are going to call as trans conductance. So reciprocal of that value is that input impedance, and also the output impedance still depends upon your output of your output impedance depends upon your beta naught. That is that we are using while calculating an amplification factor in a common base amplifier. Okay. So this is the frequency response of these two categories. While combining these two, common base and common source, what will happen? So this is that entire combination of this circuit. First we are taken as that FET amplifier. Next one is that BJT. If you combine both the things, what will happen? We are going to obtain that parameters, or by using this kind of things, what will happen? That frequency response is very high. That increasing the frequency response, and also your output impedance is at higher value. Okay. So this is at ultimately, and voltage gain is also increasing based on the number of stage using. So voltage gain is increased, is very highest value. Okay. So this is only that frequency response of your combining these two stages with your BJT. So this is our ultimate aim. Suppose they are asking that futures of BiCMOS cascaded amplifier means we have to given the statement basically like this. If they are asking the mathematical expression, you have to take as CGS, which is nothing but that output of your the common source FET amplifier. That impedance depends upon your input resistance or source resistance, and also they are given that other parameters, that is also very useful parameters. They are depends on your output impedance and also that transconductance of your second stage. GM2 is that transconductance of your second stage. So these are the things only we are going to observe or understand from this combination of BJT and FET amplifier. Okay. And the final conclusion, by using this type of combination, BiCMOS amplifier, as overall gain is increased. Generally, the common source also increasing the voltage gain. Common base is also current gain only unity, but voltage is increasing. Okay. So overall gain of a voltage gain is increasing, and also that frequency response is a compatible one for your common base amplifier. So this kind of amplifier might be used for your high output impedance, and also that wherever you want to increase that voltage gain is at a doubler value, you might be choosing this kind of combinations. This is a conclusion for our today class. Today we are taking as one of important topic. They might be using, this is also a first topic in your syllabus of your 4th unit. Okay, this is very important one. Once you understand this concept, that is easy way to analyzing that another parameters, because in our 4th unit they are given that differential amplifier and power amplifier also. So before entering to that power amplifier, we have to know why you have to go for power amplifier. So which one is giving that higher output? That is very important. The essential one is also. So that's why we are taking as today is only that limited